Hey guys, I'm going to go through some selected problems from the quiz review. So the first thing that was requested was problems from from question 2. So let's look at 2B and C. Notice for number 2 it says a projectile is blasted vertically upward with a velocity of 200 feet per second. That's my initial velocity, and it reaches a height of, and here's my position function, after t seconds. So part B says, what is the velocity? So my final answer should be a velocity. That's the first derivative. Ooh, sorry, whoopsies. Sorry, this is velocity, which is the first derivative of position. And we specifically want to know the velocity when it reaches 50 feet. Well, notice my units are in feet, so I know this has to be a position. So I want to know when S of t, my position is 50 on the way up. So the first thing, calculator, and in y1 I'm going to type in position. And then notice whenever I see this equal sign, we talked about this in class, this means I should be setting things equal and figuring out where they intersect. I should be thinking of graphing an intersection. So if I want these two things to intersect, I need to graph S of t and I need to graph 50. And I need to figure out where these cross. Now, if I push graph, notice my window's in standard settings, so the 10s, C, which isn't necessarily very helpful to me. So a trick is, if you go to zoom and then scroll down to fit, your calculator is going to take the best guess of what it thinks you want to see. So I'm going to graph that. And now I can see my curve. Well, notice I want to know where it crosses 50, so I don't care about anything below the x-axis. So I'm going to go back to my window, and I'm going to say, well, I don't care about any y values that are less than 0. And clearly it wants me to go somewhere close to 400. Right now I'm having a tick mark every 1. That doesn't really make sense, so I'm going to do a tick mark every 40, so I should have about 10 tick marks. And that's already so much better. One thing I could do to make it even better is get rid of some of this over here. So I'm going to also go to my window and say, okay, well, I'm actually just going to start at like -2 and go to 10. So now I have a pretty good view. Well, remember, I want to know where S of t equals 50, so I want to know about this first intersection. It's on the way up. Over here would be on the way down. Here's on my way up. Now, it's a little hard to see. I'm going to do my best guess. And there's my time. Now, remember, I have S of t equals 50. You guys have to show some amount of work even if you're using a calculator. This would be good calculus knowledge that you're giving me. And when S of t equals 50, when t equals 0.2583. Now I'm going to purposely do this to 4 digits. So that way when I put it into velocity, I'm rounding correctly to 3 decimal places. So now I can say, okay, well now I can check what v of t is when my time is this. Well, notice I don't have a velocity equation yet. I would have done it in part A, so I'm just going to quickly do that. So v of t is equal to 200 minus 50t. So this is going to be 200 minus 50 times 0.2583. And I'm just going to type that right into my calculator. That 8 button's getting sticky. And I get 187.083, or sorry, 085. On the key, I know that's what we had before. And we can talk about that in class tomorrow. So because I rounded to more than 4, this is actually going to be a more accurate answer. Let's look at number C. What is the velocity of the rock when it reaches 40 feet above the ground on the way down? So now I have that S of t equals 40. So when I go to my y equals, instead of 50, I want 40. And now I care about the rock coming on the way down, so I want to care about this intersection. Okay. So on the way down, when I cross at 40, so I'm checking when S of t equals 40, the time on the way down was 7.7, and then I want to go to more than 3 decimal places. It's going to give me a more accurate answer at the end. 7.7947. Okay. Well, I want to know what the velocity is at that point in time. So I'm going to say, what is V of 7.7947? Well, I'm going to use my calculator, but I'm just going to write this out so you can see it. Actually, technically, that is an accurate answer because it's, once you have it numerical, you don't have to simplify it, but we'll type it in anyways. And I get a value of -189.5. Now, I should be giving units. We didn't ask for it in these problems, but I'm going to give you a hint that on the quiz we might. So this is a velocity, and I know my units are feet in seconds, so it's going to be -189.735 feet per second. And I'll squeeze them in up here too. Okay, so that was number 2. Let's go on to another problem. And if you need to pause and take a look at those, you can. Moving on to number 6. Now, if you looked at the key, you'll notice that we said no calculator. If this were the actual quiz, for this quiz, we're going to let you use a calculator for everything, but I'm going to do this one without a calculator because you need to know how to solve these by hand. So let's take a look. The first thing says write the acceleration function. Well, I was given velocity. So acceleration is the first derivative of velocity. Remember, 1 over pi is a number. It's like 1 divided by 3.14. So the derivative of a number is just 0. The derivative of this, well, the derivative sign is cosine. I'm plugging in stuff, so I have to multiply by the derivative of stuff. Technically, we're done, but I'm going to simplify this. That's going to help me in later steps. I have a 3 cosine of 3t. Okay, well, now it's asking me if it's speeding up or if it's slowing down. If you remember from class, if it's speeding up, it means that velocity and acceleration have the same sign. It's slowing down if velocity and acceleration have different signs. And by different signs, I mean like positive or negative. Trying not to take too much space in here. So let's see if we can figure this out. Let's check for velocity first. I need to know what velocity is at pi over 4. So that's going to be 1 over pi plus sine of 3 times this. So sine of 3 pi over 4. Well, sine of 3 pi over 4 is root 2 over 2. It's in the second quadrant, so sine's positive. So a positive plus a positive is positive. We don't actually care what the actual value is. We just need to know if it's positive or negative. Now I'm going to do acceleration. That's 3 times cosine of 3 pi over 4. Well, cosine in the second quadrant is negative, so 3 times a negative is still going to be a negative. Okay. Well, since velocity is positive and acceleration is negative, I'm going to use my blank is blank at blank because blank. So I'm going to say the object is slowing down at t equals pi over 4 because velocity, or I'll say velocity pi over 4 was positive and acceleration at pi over 4 was negative. So whenever you see explain, you need to write a good sentence. So there's my blank is blank at blank because blank. Okay, let's try part C. It says on the interval pi over 4 to pi, what is the velocity when the acceleration is 3? So I need to know when is acceleration equal to 3. Now I'm going to run a little low on space, but that's okay. Okay, I'm going to divide both sides by 3. And now what I want to think about, I'm going to ignore this 3t for a minute. I want to think about when cosine has a value of 1. Now I have this restricted interval, so I don't need to think of like all of the infinite amount of times when cosine equals 1, but stuff around here. I know that cosine equals 1 at 0 and at 2 pi. Okay? So theta, this thing here, is equal to 0 or 2 pi. So I'm going to check when theta is equal to 3t and when 2 pi is equal to 3t. Because whatever, so we're saying cosine of what is equal to 1? Well, cosine of 0 is equal to 1. Cosine of 2 pi is equal to 1. Well, 0 is 3t. 2 pi is 3t. So I need to figure out what actual value makes that work. So if I do this, I get t equals 0. If I do this, I get t equals 2 pi over 3. This is the only one that's actually in my interval of pi over 4 to pi. Well, let me show you that this works, okay? If I plug in 2 pi over 3 into this, or let's even do it up here, that's going to give me, so 3 times 2 pi over 3 is 2 pi. Cosine of 2 pi is 1. 1 times 3 is 3. So that's why this time works. Well, they're not actually asking me for the time. They want to know what the velocity is at that time. So the last thing that I need to do, and I'm going to see if I can squeeze this in somewhere, is figure out the velocity. So I want to know what v of 2 pi over 3 is. Well, that's going to be 1 over pi plus sine of, well, if I plug that in times 3, that's going to be 2 pi. Well, sine of 2 pi is 0. So this is going to be equal to 1 over pi. Okay. So let's move on to number 7. Sorry guys, I can't zoom in a little bit more. Once I start a video, it won't let me zoom. So let's try number 7. It says 2 particles move along the x-axis in their position functions on this interval. We talked about this in class, how we print it as a typo, so make sure you check this. Are given by the following equations. How many values of t do the 2 particles have the same velocity? So here's my key word. Remember, these are both position functions. So this is going to be the derivative of position. Ooh. Okay? So if I want to figure out when they have the same velocity, when I see same, I should think equals. And I told you guys when we see equals, we should think graph and intersect. So in my calculator, in y1, I'm going to have tan of 2t. Make sure your calculator's in radians. In y2, I'm going to have 4t minus 8. In y3, I'm going to have the derivative of y1. And in y4, I'm going to have the derivative of y2. And we're testing it at all points, so that'll graph, right? I want to know when y3 equals y2. So let's see if we can do this. Go into my calculator. Let's clear everything out. Okay, I have tan of 2t. I have 4t minus 8. Now I want the derivative, so math 8 of d dx of y1, so vars, y vars, y1, all values. Now I need to do the derivative, so math, if you don't remember that it's 8, just scroll down till you see n deriv, that's derivative. Should be an x. Now I want y2, and that should be an x. Now I'm graphing the derivative, so I don't care about these two up here. So I'm going to scroll up to y2 and turn it off, y1 and turn it off. So I'm only graphing my derivatives. Okay. So my window's all weird from my previous, so I'm just going to go to a zoom 6. That's zoom standard. That'll just give you like the 10s. That's a good place to start. Ooh, this looks pretty. Remember my interval, I should have fixed this before. My interval is only from 0 to 5. So remember right here, my interval is from 0 to 5. All right, we'll fix that in a second. This gives you a moment to take a break. The last one should graph quickly because it's just a line. Okay. It says how many values of t do they have the same velocity? So I know that this is 1, 2, 3, 4, 5, so I can guesstimate, but I'm not totally sure about that one. So I'm going to go to my window, and for my x values, I'm only going to go to 5. My slope is just 4, so I'm going to change this just to about that, because that's all I need to see. So because 4 is in the middle. So now it's going to be easier to see. It's still going to take a minute for it to graph again. But now I only have from 0 to 5, so it should be much clearer how many intersection points I have. One, 2, 3, 4, 5, 6. So making that screen smaller made that really clear, so I have a total of 6 intersection points. This one's a little harder to show work on, but one great way to do that is just to show what you put into the calculator. Okay? Okay, we got a couple more to do together. Remember, you don't have to watch this whole video, skip to the ones you want. Now, my guess is a lot of you asked about 10 and 11 because we made some mistakes on the key. So if you go look on Blackboard now, it'll be updated, but also go through these anyways. Let's look at number 10. If I'm going to do the derivative, it takes a little while to isolate y by itself, so we're going to use implicit. So the derivative of cotangent is negative cosecant squared of stuff. It's not just y or x, so I need to multiply by the derivative of stuff. I was dealing in terms of y, so I need a dy dx. The derivative on the other side is 2. So if I'm going to rewrite this, I have a dy dx equals 2 divided by all of this stuff. Well, notice this is negative, so I'm just going to throw that negative at the top. So when I divide by all this, I have the negative 15y squared cosecant squared of 5y cubed, which I believe is a. And they just wrote it as cosecant times cosecant. That's the same as cosecant squared. Okay, let's look at number 11. And again, I'm sorry, this isn't zoomed in more. Number 11, find dy dx given this. Okay, well, the derivative of this is just going to be 3 equals the derivative of cotangent is a negative cosecant squared of stuff, right? Now I need to multiply by the derivative of stuff. The derivative of x is 1 dx dx. I don't have to put a dx dx. The derivative of y is 1, but I dealt with y, so it's going to be a dy dx. Okay. So, so you have a couple ways that you could go through this. One thing would be to distribute next. And you have a negative cosecant squared of x plus y minus, now we're going to distribute to that, a negative cosecant squared x plus y dy dx. I'm going to add this to the other side. And now I'm going to divide by this stuff. If you were to look at the key, you would notice that it's this minus 1, because these are going to simplify to a minus 1. The second answer there would be totally acceptable. Looks a little different than the key, but they're the same because, again, before on the key it's just this term here minus 1 because this has a value of negative 1. Okay, last one to do together. We're going to do number 13. Number 13, find dy dx at a point. So let's start by taking the derivative. Now before I take the derivative, I'm going to rewrite this as, oopsies, not an equal sign, 3y to the negative 3 plus 2x equals 11. That's going to make this go a lot better because the derivative of this is going to be a negative 9, y to the negative 4. I dealt with y, so it's a dy dx plus 2 equals 0. Okay, As soon as I've taken the derivative, I can plug in my values. So it's not asking us to just solve for dy dx. They want it at this point. So I'm going to plug in 4 for x and 1 for y. So that's going to give me a negative 9 times 1 over y to the 4th plus 2. Well, that's just 1. So we have a, ooh, I forgot my dy dx. So I'm going to have a negative 9 dy dx equals a negative 2. So dy dx at the point 4, 1 is equal to 2/9. Okay, so those are the questions you guys asked me to go over. Hopefully this video was helpful, and I'll see you guys tomorrow for your quiz. Don't forget you're going to have to show work on every problem. Make sure if it asks for units, you fill that in. And I would make sure you study your gold sheet, specifically the velocity and acceleration one, because there is going to be a memory portion to your quiz. So I'll see you guys soon.